Okay, the last set of notes that we're going to go over is temperature scale. And there's a couple different reasons why measuring heat is so important in science. We measure heat because if you think back to that little chart that I showed you about the heating curve of water, that actually applies to any substance, anything that we're studying in science with matter. It allows scientists to accurately compare and identify changes that are occurring in matter. Okay, we need to know that because I need to know what temperature it's going to take to melt down maybe a solid, or what temperature it's going to take for this liquid to change into a gas. So that's why it's important in science. If we look at Fahrenheit, there's 3 different temperature scales, the first of which is Fahrenheit. That was actually invented in 1714 by a man named Daniel Fahrenheit. He invented the first temperature thermometer. It was actually made of mercury, so scale that used mercury, which is actually kind of harmful to us now. We mostly all use digital scales. But Daniel Fahrenheit used mercury, and mercury reacted with heat to be able to accurately tell temperature. And he came up with some points, some important points, and that is the temperature that water freezes, we know as 32 degrees, and the temperature that water boils is 212 degrees in Fahrenheit. The United States is actually the only country that uses Fahrenheit scales as our temperatures. And there's actually a 180 degree difference. That means if I subtracted 212 minus 32, that would be 180 degrees difference between our freezing point and our boiling point. If I move down to Celsius, Celsius was developed by a man named Anders Celsius in 1742, and he came up with an easier way of telling temperature or measuring heat. And he used what's called the centigrade scale, based on 100 degrees between our freezing and our boiling points. So in Celsius, 0 degrees Celsius is the degree where water freezes, and 100 degrees Celsius and 100 degrees Celsius is the temperature where water boils. And then our last scale is the Kelvin scale, and the Kelvin scale was developed by a man named Sir William Thomson, which was later changed his name to Lord Kelvin, and he designed what's called the absolute scale in 1848, which was almost a century later, and it identified the lowest possible temperature that can occur in the universe. He called this lowest possible temperature absolute zero, and it was defined by a complete absence of heat and motion. And the Kelvin scale starts at 0 degrees and moves up. There is no negative numbers in the Kelvin scale. And then I did a little experiment with water balloons relating to heat capacity. And water is unique for several reasons, but one because it has a very high heat capacity. Water is able to release a large amounts of heat energy. That's because when I heated the balloon in class with the flame, when it had air in it, the air has a very low heat capacity, and it actually melted the balloon and caused it to pop very quickly. But when I heated the balloon with water, water had a high heat capacity, meaning it was able to, instead of concentrating the heat in one area of the balloon, it was able to release the heat energy into all parts of the balloon, so it wasn't able to pop as quickly.